Okay, we're going to go through some details of the cell cycle with meiosis. I'd like very much for you to listen to the pattern. There's an awful lot in common between mitosis and meiosis, but I do think that you just noticed how really long this process is. That's a difference. So let's go up to the top. The opening segment talks about cell cycle as your header, and then we've got an interphase. Interphase is very similar to what we saw in the cell cycle with mitosis, where we have a growth phase, synthesis where DNA is replicated, and then another growth phase. Next up, we have the beginning of meiosis. Meiosis happens in this process 2 times. So you'll see the first meiotic division, then we'll see cytokinesis, and then we'll see more meiosis. So let's go up to the top. First, in prophase 1, you're going to see the nucleus is coming apart. Chromosomes are lining up together. That's very unique. This is where crossing over can happen. Then all the pairs of chromosomes line up in the middle. If the pair of chromosomes line up this way versus this way, we call that independent assortment. It's how they're lining up with each other. Then the pairs separate in anaphase. And then we have a little bit of pause where we can see the cell pinching. We get new nuclei. That last little piece where those 2 cells come apart and become, when that one cell comes fully apart and becomes 2 cells, we call that cytokinesis. And this is the first haploid cell. There's a haploid cell here and haploid here. In humans, that means that this one's got 23 chromosomes and this one's got 23 chromosomes. Unfortunately, the chromosomes, however, are still replicated. So the chromosomes still look like this. That's not okay. That's 2 exact copies, 2 sister chromatids. So we've got to divide them apart. And therefore, we have to go through meiosis a second time. So we loosen up the DNA nuclei again. The chromosomes line up in the middle in metaphase. The 2 sisters get ripped apart this time in anaphase 2. And then new nuclei are forming around that small haploid number of chromosomes in both sides. The cell is pinching, and then finally, in the last of the cytokinesis, we end up with 4 cells. Each one is different from the others, and they all have half of the chromosomes that the original cell had. Up here, we had a cell with 46 chromosomes. Down here at the final product, we have 4 cells, and each of those cells has got 23 chromosomes.